Notice, and this is a typical copyright. We continue with mathematics syllabus for CSEC, which became effective in May-June 2018. As of January 2026, the syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself remains unchanged. The main planned change to this CSEC level math exam is to split the exam into two parts. As it relates to the current structure or format of the CSEC math examination, there is a paper 1 which runs for 1 hour and 30 minutes, and that paper consists of 60 multiple choice items from all sections of the syllabus as outlined below. Paper 2, which runs for 2 hours 40 minutes, consists of 10 compulsory structure type questions from all sections of the syllabus. There will be no choice. All sections will be tested, as I said, with compulsory questions. Paper 3.1 or 031. If you are in school, this is better known as the school-based assessment, where your teacher will give you some kind of project to investigate, collect data, and then analyze the data if you are in school. If you are not in school and you are writing this exam as a private candidate, then you would write 032, which is alternative to this paper up here. It runs for 1 hour. Instead of collecting your own data, you will be given data and asked to do statistical analyses on the given data. As it relates to the marks and the profiles, there is a knowledge profile, a comprehension profile, and a reasoning profile. From paper 1, 18 questions or 18 marks will be based on knowledge, 24 on comprehension, and 18 questions or 18 marks from reasoning, which would give you 60 marks from the 60 questions, which will have a weight of 30% of your final grade, and so on, paper 2, paper 3. Total 200 marks, which will be expressed as a percentage, and that will determine your final grade. As it relates to the sections of the syllabus and what videos have been done so far, section 1, 2, and 3, all 51 of those videos have been done and published in their entirety on YouTube. From section 4, 5, 6, and 7, all of those have been done, and some of these videos have been published on YouTube in their entirety. 5 from section 4 out of 17, 5 from section 5 out of 18, 7 from section 6 out of 22, 9 from 26 from section 7. We are now at section 8, geometry and trigonometry. This is the 23rd of 26 videos from this section. Once this section is finished, obviously, we will need to go on to do section 9, vectors and matrices, and I will have to push back that schedule a little. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. Still on section 1, number theory and computation, I have divided this section 1 into 33 videos, and they are all available on YouTube in their entirety, as I said before. But this was done specifically as section 1 forms the foundation on which the rest of the syllabus is based. How well you can handle this section, section 1, will predict how well you will be able to do the rest of the syllabus. If you're having problems with these, you will not be able to do the rest of the syllabus well. Here is a reminder, if you plan to write this CSEC exam, you need to know the times tables from 2 to 12, since calculators are not allowed in paper 1. Still in section 1, number theory and computation. Most of these videos are even applicable in primary schools, that is from section 1, where the students themselves can look at the videos either before they come to class to deal with that topic or after as reinforcements. Teachers can use them in the inverted classroom, and specifically parents who may not feel comfortable teaching their children these math over here that you see, the parents can get a lot of help here. For example, if you consider this blue box here, let me expand it. Video 6, remember we are still in section 1 of the syllabus, talks about addition, subtraction, multiplication, and division of whole numbers. That is work done in grade 3 in the primary school. Video 7 deals with addition, subtraction, multiplication, and division of decimals. Work done in grade 4. Video 8, addition and subtraction of fractions, and video 9, multiplication and division of fractions. Work done in grade 5 and 6. And you have the rest of this section 1, which is essentially work that should be done in the primary school, like LCM and HCF and so on. Remember, there are 33 such videos in section 1 from the CSEC syllabus. If you are looking at this video, you are looking at the channel ROEL 922. If you rearrange it in playlists, you will notice there are a number of playlists, but the one I am talking about right now is this one here, which is section 1. As I said, most, if not all, of section 1 is work done in the primary schools. Don't be misled by the title, CSEC Mathematics, section 1, Number Theory and Computation. It is not as difficult as it sounds. Section 2, Consumer Arithmetic. All 12 of these videos from this section have been published on YouTube in their entirety. Section 3, Sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, Measurement. Some of these have been published on YouTube in their entirety, as indicated here in yellow, the others partially. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 5, Statistics, same principle. A number of these videos have been published on YouTube in their entirety, the others partially. Again, please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 6, Algebra, same principle. These videos that you see indicated in yellow here have been published on YouTube in their entirety, and the others partially. Keep in mind that those that are partially published, then they deal with each of these objectives partially. For example, law of indices. Some of that has been done in this video, even though it is only partially published. And as I already pointed out, if you need full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 7, Relations, Functions, and Graphs. These 9 videos have been published on YouTube in their entirety, and the others partially. Again, please see directions in the description below for full access to those videos that are only partially published on YouTube. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2, especially to get more practice questions. CSEC recommends these in its syllabus. From those, I would recommend these last 2 here. as seen on the next slide, since they form a very good two-volume set of math textbooks that is quite adequate for the current and future proposed changes in the structure of the CSEC math exam. This is a picture of Volume 1, Mathematics, a Complete Course with CXC Questions by Raymond Tulsi, and this is a picture of Volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page for that website looks like, which is this. You would have to register first and subsequent to that, sign in. Again, that is the URL. This URL will be listed in the description of this video below, so you can easily click on it and be redirected to this website. Another reminder that this formula sheet you see on the left here is provided for the CSEC math examination papers. It is also included in a full copy of the syllabus if you have such a copy. If you don't, then there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet. I am going to state the obvious here. You do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the examinations for mathematics. And this is the below part of that same formula sheet. While you do not need to memorize these formulae here, you do need to know when and how to use them. So section 8, geometry and trigonometry. We have finished all the objectives on that page. And there's one objective on this page completed. There's one objective on this page completed. On this page, objectives 7 to 11, all of them have been completed. On this page, we have completed that one, and we have completed this one in video 22. So now we are here at objective 14, and this is video 23 out of 26. So we have 3 more to do to get the objective 17. These 3 are related. Notice here you are defining trigonometric ratios. Here you're looking at real life examples. And in this video, which is the next video, we will be doing calculations. So in this video here, we will not be doing any calculation, the one we are doing right now. Just a reminder that we completed up to here 8_13, video 22. Out of those, these 8 are published in their entirety, the others partially. I am now here, 8_14. This is video 23. When this is finished, it will be partially published. As it relates to the remaining 3 videos, this one will be published in its entirety, and these other 2 partially. So from this section, 9 out of 26 videos will be published in their entirety. So we are here. Objective 14, video 23. And it says, relate objects in the physical world to geometric objects. And you are further told here in the explanatory note to deal with angle of elevation, angle of depression, and bearing. So that is what we will do. This is a print screen from the syllabus, which confirms that that is what we are doing. Now, angle of elevation and angle of depression are basically the same concept with one minor difference. While they both involve vertical perspectives, one is based on your looking up and the other is based on your looking down relative to an imaginary horizontal line at your eye level. Don't worry, I will explain it. So consider this object here. Let us say it is the floor of a room. And over here you have a wall. And in that wall, you have a window. Up here is the ceiling of the room. This is another wall. I'm not showing you the door. And in this room, we have an office worker. If you notice carefully, there is an imaginary line here from the eye of that office worker to the middle of this window. So that would be W and E. There is an imaginary line from E to W. That is called the horizontal at the eye level. Remember, it is imaginary. Now, while the worker is working there, you notice something somewhere at the top here. Maybe a gecko climbing up this wall from the corner of his eye. So he looked straight at it like this. This is called a line of sight. Notice he looked up. The angle from this horizontal to that line of sight may be 20 degrees or more or less. But let us say it is 20. Now that angle is called the angle of elevation. Let's say it is approximately 20. If he were looking at a ceiling fan here, then it may be 45 degrees. But whatever angle this is, it is called the angle of elevation. Well, this gecko probably had a bad day and it fell from up there as it was trying to climb up here and go to the ceiling. Any self-respecting gecko would never fall, but this one probably had a bad day. This gecko probably had a bad day and it fell from here down to the floor. And I could imagine it glaring at the office worker. Looks like it is glaring at the office worker. So the office worker took his eyes off from up there and looked at the gecko down here. Notice what happens with this angle. Notice now that this is an angle below the horizontal at eye level. Let us say it is 22 degrees. We don't know what it is. Let us say it is 22 degrees. That angle below the eye level is called the angle of depression, whether it's 22 degrees or whatever. So let's forget the gecko for the time being. Note here that when you take pictures of people standing up, let us say this is the height of the person from there to there. Forget about the wall for now. Keep this horizontal at your eye level somewhere halfway from the person's head to the person's foot. If you are closer to up here, this top part will come out big and nice, too big, and the below part will come out too small. If your eye level is down below here, then the top part will come out small. So your picture will be distorted. So you're taking a picture of somebody standing, make sure your eye level is somewhere about the middle, say at a little above the waist, say at the navel level. So you could take a properly proportioned picture. All right, so that was just in passing for your information. So let's forget the gecko and the taking of pictures of people standing. Let's continue with this objective. So now you understand what an angle of elevation is. Your line of sight is above this horizontal at eye level. And you know what an angle of depression is. Your line of sight is at an angle below this horizontal at eye level. We will consider several examples of objects or situations in the physical world where angles of elevation and angles of depression exist without your even being aware that these were the situations. You never thought of them as angle of elevation or angle of depression, but they exist. We will not do any calculation in this video. That's for the next video. So, what about bearings? We are not talking about those metal or otherwise rollers that reduce friction between moving parts of a machine. Not those. We're not talking about those. Though I will show you some pictures here so you would know what we are not talking about. This is a picture of a ball bearing. This is a picture of a needle bearing. This is a picture of a taper bearing. This is a picture of an angular bearing. And here you have a picture of a cylinder bearing. It's not much different from this one over here, except this one is used in upright positions and this one is used in horizontal position. This is a picture of a plain bearing. This is a picture of a truss bearing. This is a picture of a roller bearing. This is a picture of a magnetic bearing. And this one here is a picture of a fluid bearing. And there are other types of this kind of bearings. Okay, we are not talking about those. This is not what we are dealing with in this objective. Not that kind of bearings. With angles of elevation and angles of depression, we are dealing with vertical perspectives, up and down. With bearings, we deal with horizontal directions, counting clockwise from north as the starting direction, which is 0, 0, 0 degree, up to 360 degree, which is back to north. For example, this is a compass face. If you begin at north here, go all the way around to south, that's 180, go all the way around to west, and come back here, back to 0 or 360. Here is another example of a compass that you may see in a Jeep or something that people use out in the desert or rocky areas when they go out exploring. This shows the direction that you are traveling in. And this is another example of a compass that gives the bearings you are traveling in or the direction you are going in. To help understand better, consider this compass face. You have some letters around here, like N for north, E for east, W for west, and S for south, from which you get news. N, E, W, S. That's the news, like in the newspaper or the news on the TV and so on. That's where you get news from, the 4 directions of the compass. And then you have some midpoint directions between those. And there were some others named here between there to there. There are 3 other names, but we wouldn't bother about those. We will look at the simpler method, which is the bearings method. If you are facing or traveling in this direction here, you know it is north. But in terms of the bearing, your bearing is 0, 0, 0 degree. Or less common, you could say it is 360 degrees because you go all the way around and you come back with 360. But it is north, which is 0, 0, 0. So the compass direction will be north. The bearing will be 0, 0, 0 degrees. Or let's say you are facing this direction. It is east based on this compass. But what is the bearing? As you could see, there is a 90 there, but normally you use 3 digits, so it is 0, 9, 0 degrees. So what about this direction? You are facing this direction or you are traveling in this direction. Again, you could see a 180 here. Now this has 3 digits. So if you travel south, that's the direction, the bearing is 180 degrees. So south direction and 180 degrees bearing, they are the same. And if you travel or if you face west, notice 270 is there. So the west direction is at a bearing of 270 degrees. West direction and a bearing of 270, they are the same. What about this direction? You could say northeast, that's the direction, but what is the bearing? It is 045 degrees. That is 40, this is 50, so this between here must be 45. So now what about this one? We don't have a name attached to it. And this is where bearings make it easy, because you could name any one of these numbers around here to get an exact direction. You notice 150 here. So this is at a bearing of 150 degrees. What about that one there? If you are facing that direction, or if you're flying in that direction, or if you are sailing in that direction, or if you are walking or hiking in that direction, what direction is that? Well, we don't have a name for the direction, but we do have a bearing. It is 340 degrees. Now, with angles of elevation and angles of depression, we are dealing with vertical perspective. With bearings, we deal with horizontal directions, counting clockwise from north as the starting direction, which is 0, 0, 0 degrees, up to 360 back to north. We said that before. Now, if you think about this seriously,